Good evening, everyone. My name is Christopher Urbane. I want to thank you all for calling in tonight for this evening's ASQ Inspection Division webinar. Today, the topic of our presentation is called Quality and Organizational Development for the New Era. We have a very special guest this evening. Contrary to most of the presentations we've hosted this year, Azhar, who is the speaker of tonight's presentation. He's not a personal friend of mine. I actually read about this company that we're going to hear about tonight in an article that I found on a website, and I reached out to them, and Azhar called me back pretty much quickly, interested in sharing this really cool, innovative product that they have on the market. So a little bit about Azhar. He graduated from Cornell University. He's a serial entrepreneur with multiple startups under his belt in vision systems, analytics, business intelligence, and machine learning. So I thought this would be a very innovative presentation for all of us to learn a little bit about PhotoGAUGE, their technology, and how it relates to the inspection division that most of us work in today's real world. With that being said, Azhar, please take over the presentation from this point.
Oh, great. Thank you, Chris. Good evening, everyone. Thanks for joining us this evening, and thanks for Chris for giving me an opportunity to talk about what we have been doing over here at PhotoGAUGE, and in today's environment where you have lots of commodity cameras and artificial intelligence and machine learning. Those are the buzzwords that you keep hearing a lot about. So as I was thinking about, what would be an interesting topic to discuss for this evening from quality assurance and inspection point of view, which, most of you guys are involved with, I thought maybe a good starting point might be to just start with the concept of innovation, and that's such a integral part of human DNA. And innovation is it's an iterative process. And it evolves over time, just as humans have evolved into where we are here today, millions of years later, as opposed to other types of animals. It's the inherent ability of the DNA to evolve things. So, with that, keeping that in mind, that innovation is an evolutionary product, let's take a few examples and just sort of start to put things in context. That you start out within the case of transportation industry, where many of you guys are involved in. It's as simple as starting up somebody came up with a wheel. And then maybe about 120 years ago, it formed into a very simple car. And today, the conversations into transportation is revolving all around Tesla. And that's like electric car, autonomous driving, autonomous pickups and everything like that, and a perpetual way of the cars driving themselves and learning from that whole experience. Through the evolution of various different technologies which have brought and made Tesla feasible, which is function of LiDAR and commodity cameras and access to a ridiculous amount of computational power just available within the automobile itself. To another example, which is communication, where the telephone has started out with just a very simple dialing thing to going into a cellular phone, and then what Steve Jobs made possible with the iPhone, which is about 10, 12 years old, where it has the capabilities of a supercomputer from maybe 20, 30 years ago. It's able to do all those kind of things. That is no longer just a phone or a communication device. It's a camera, it's a radio, it's ability to access data from your corporate networks to looking up information online and whatnot. And sort of looking at one of the final key components, which is enabling today's technologies, is just the data processing. where you would have a room full of diodes and triodes, which will be able to barely do simple mathematical calculations, to evolution into a laptop, which is obviously very powerful instrument today, to where cloud computing is today, where you can take information and distribute it across thousands and thousands of machines, and literally get the results back in a fraction of a second. And that has all been enabled by the ability to do the processing on the fly. So as you look at it, the three things I spoke about, which is sort of transportation to data, to communication, to data processing, and those are the critical things which which is enabling all sort of the next set of innovative products that and solutions that are coming out. And that's sort of also a story for PhotoGAUGE, where Shankar, who is the brains behind this technology, he did a lot of his research work at Urbana-Champaign in mechanics and artificial intelligence and stuff like that, and went on to work for IBM, T.J. Watson Labs, and Metronics and Intel, and did a sabbatical over at Google. And then I had sort of worked on Autodesk, and worked on a company called RIA, which is in face detection, face recognition space in the early days of what you would call computer vision back in early 2000s or so. And that's what allowed us to sort of go through an iterative process over the past 5 years, where the experiences from the CAD world to the machine learning and computer vision world of what's in the photographs, to a lot of the research and innovation work that Shankar had been involved in, right? Given a photo, what's inside the photo? Can you look at the size of it? Can you see how much change has happened in this photograph? Has turned it into what you would call PhotoGAUGE. So here to just sort of talk about what inspection is an extremely broad term. So let me just ask a few questions, such as how many bars are in here? That's not an easy problem. Here is here's a window in your house, and you want to know if the blinds that you're getting cut over at Home Depot, will they fit here? And if you're looking at it, if you take this measurement and somebody else takes these measurements for these windows, are they correct? What is the correct definition of those windows and for the blinds to fit? Or for that matter, here's the aircraft tire. Is it safe? Whatever the definition of safety might be. Is it the thread depth? Is it the fact that it's perfectly circular or not? Or or what kind of wear and tear may be happening on it? And here's a picture of a mine, and you want to know, is the mine safe? Will it collapse? Where is all the material present, and what is it, and what do you need to know about that? So those are some of the few examples, and one of the common theme across these 4 examples are that these are all visual inspections, where human operators were involved, whether that was counting of the bars, or the sizing of the windows, or the thread depth of the aircraft tires. So in all these cases, these are all visual, and they all involve data collection, where somebody was doing that work, writing it down, or then transcribing into a computer, and so on and so forth. So there is, so many different places where things could be interpreted very differently by human operators, and they were all visual in nature. So that brings us to a question. So what is PhotoGAUGE? So what PhotoGAUGE is basically using, everyday commodity cameras, whether that's in your cell phones or the webcams or those, different types of cameras available in the market. Using those commodity cameras and a set of, computational algorithms that has been developed over the past 10 years or so between Shankar's research and during the last couple of years of development at PhotoGAUGE, and along with the computing power. So you take a photograph, you upload it to the cloud, and complex algorithms work on it, and from there, you're able to answer the question depending on what your definition of inspection or the question you want to ask, whether you're looking for like, hey, is the part correct? Is the part defective? Does it have all the components that you're looking for present on it? Does it conform? Is it round? Is it flat? You know, it all boils down to what is the question that you're asking. And if you can look at a picture and see that, like, oh, I can actually, it's a bit visible in the picture, but only you would know what the question is. PhotoGAUGE is able to answer that. And so what's the process? The process is quite simple. It's just as simple as 1, 2, 3. You take a picture, you upload it to the cloud, and you get a report back. And the report is basically based on whatever the question you had asked. We return the answer to that. So given that, so you know, what are the kind of questions that PhotoGAUGE can answer? So here's an example of like, okay, is the part good or bad? So here's an example of some gear faces, and they want to know, can you automatically recognize a defective face in it? So, you know, PhotoGAUGE just, you know, the human operator just takes the picture using a commodity camera phone. The picture is taken, and then we are able to figure out if it's defective and whatever the definition of defective is, such as if it's dings, nicks, or scratches, or the number of dings per face. You know, 1 ding is okay, but 2 is not, or 3 is not. Or the size of gouge is okay as long as it's less than 2 millimeter, but if it's more than 2 millimeter, it's not. And how is that done today? It's done all by human operators just looking at these things and making a decision. And that can it can easily be operated with a camera-based question using machine learning. Let me go to the next slide here. Here's a hydraulic engine, and a picture is presented to it, and it just what the client wants to know is that, like, are all the components present? So this is an example where the JT file, which is another, you know, as a hybrid CAD format, and the JT file has 2,400 different permutations that they can make from this model, with the slight changes in the solenoids or the shafts or the bolts present. And in this case, again, a human operator will take between 2 to 4 hours to determine if the assembly is correct or not, because there's so many checks to do. Here, you take a picture and it automatically recognizes, given a model, is like if are all the components present or not. Here's a classic quality control question: is this gearbox meets the requirements, all the specifications? So you take the picture and you have compared it against a CAD model, and automatically generates a full GD&T report of, like, are the surfaces parallel? Is this, you know, is the cylinder really round? What is the radius or the curvature of the corner of the gearbox? What is the center-to-center distances between these holes? Again, these are not a trivial measurements or questions to ask. It's like, how would you measure the center-to-center distances between the holes, as you can see in the CAD model, right? Here's a classic one for auto industry, where these are the, sheets, which are already pre-cut and are ready to be fed into a stamping mold to stamp out the door. And this is a classic case where they want to know the count of it. And I think the count is about 470 sheets. And then how do they do that today? Well, they sit there and they have a human operator count it. They'll say, okay, why don't you weigh it? Well, the problem is these are cuts. And at this kind of a number, at 450, if each of these things are off by even, 1 millimeter, 2 millimeter at 450 sheets, you can easily add 2 or 3 more sheets, because of the weight problem doesn't answer that. And if the number of sheets are not correct, the whole production comes to a halt, because these are automated machines. So there's a counting problem. And another example, like, here's a mold which is being made, and and they want, like, the mold has, like, about, in this case, about like 100 holes or so, and they want to know, like, if the number of holes are correct and present in their actual location. And again, it's like, how would you verify these things? And there is a human operator who just tries to go up against counting it, and it not only takes, like, 10 to 15 minutes, but the highly inaccurate method, because If it turns out like you counted 99 or 102, which one is correct? Did you count it wrong, or there are less holes, or there are more holes? And if you are missing one or two, which one are those? So here's, can you tell me the location and presence of all the holes? Here's an example of like, a die where like, it's a forging die and they're hammering out parts, and they're like, okay, how the die is deteriorating after usage. So they had pulled out, parts, at every 100 parts have been hammered out, and they could measure the change in the actual parts that are being formed from it, as well as, or like they can just take a picture of the mold of the die itself and see how part is how the mold is changing with usage. Now, in order to do that, you have to take this mold over to a CMM facility or something like that, because it's 2,000 pounds. It's not easy to move. The accuracy is hard. Or you can pull the camera out from your cell phone camera, take a small short video of it, and get all that information right there on the job floor. Here's an example, like as a wheel where like you want to know, that the client wanted to know is like, is there sufficient stock present? Because as they're going through the process, they are, do they have enough stock present? And you don't want to find that out after the wheel is finished, that there was, it was already out of tolerance and it has gone out of tolerance somewhere like, halfway through. So here's a case where they did a quick scan of the thing on the machine floor, on the cold forging floor, and then they wanted to get a cross section of it, and in which case it is showing that there is just not enough stock present in certain locations. So there is no point in continuing with the manufacturing process, because this is going to be out of spec anyway, because there is just not enough stock present in multiple locations well before the part was finished. And it could be as simple as distance. This is an example where like you have a block which may be where you want to know if the surfaces are flat or not, and they are within, and they have enough it meets the minimum requirement before they're shipping it out. And as simple as, while it may look very simple, that you can take a tape measure and make these height, width, and length measurements, it's actually a bigger problem, because they want to know, they can't tell if the sides are parallel or not, if they're square or not. And not only that, like, your tape measure can be slightly tilted as you're, pulling it from one side to the other at these kind of lengths, which is about 8 to 10, 5 to 8 feet. It could be easily off by a quarter of an inch or something, and that's resulting in shipping out the wrong part with the wrong amount of stock on it. So, and is the tire circular? Right? Really that simple, but it became very, very complicated. Or here is another example where, like, the client wants to measure the wear and tear on the BOEING tire after every 50 flights or so. How much thread is left on it? You just don't have the time to basically take the thread measurement. If you use the thread depth measurement, you might be able to take 3 or 4 points on it and get the data just like by sticking a quarter kind of a thing in it. But here, as you can see in a color map, it's showing the wear and tear, and not only that, it tells you how by showing it in various different colors, where it shows red, is like you still have plenty of stock present, but at -4 millimeters, like where it shows purple, is a lot more wear has happened, which is something you would not have figured out by just taking a depth measurement tool and getting a quick measurement from it. So with that, we'll open up for questions you guys may have.
All right, so I know you have a couple different examples that you want to show as well that you had from some other facilities you visited. I did write down a couple of questions I wanted to ask too, and hopefully that'll give some folks some time to type in some questions into the chat box. So sure. My first question, no pun intended, I consider you to be a visionary in this industry because you've been involved with this for quite a while. Where do you see this industry going and taking shape with in the future? Where do you see the visual inspection industry heading?
You know, the visual inspection industry, where it's heading, it's like you know, I'll be surprised if it's in the next 5 to 10 years, you know, you will be doing all these inspections using, you know, the iPhones or the mobile, any of these mobile phones in your pocket by just taking a simple picture of it. Because it's just the sheer amount of the computation power which is available, or what you would call, you know, the cameras are now evolving into smart cameras. And I think the latest version of the iPhone 12, which has released about a month ago, it has a depth sensor on it as well, right? So you are able to quickly, you know, take it out, you know, shoot a short video, like maybe 10 to 15 seconds of what you're looking at. And, you know, just tapping it and just say, hey, you know, is the mouse on that I have, is it of the right shape or not, right? Or to be able to just say, like, you know, can you automatically measure the curvature of this, the mouse that you have on the table? You know, it's really moving towards that people will be able to get those quick answers very easily, especially a lot of the simpler things where you want to know, length, breadth, and height, or the ability to take a picture of the door that you want, you know, that needs to be replaced, or the dishwasher in your kitchen needs to be replaced, and you want to know the exact size of those kind of things, where you are taking those measurements with tape measure, and that can all be replaced by that. Or for that matter, I mean, the inspection moving towards in the logistics industry, which is another common theme that we keep hearing about, is that, like, hey, if I take a picture of this part, can it tell me what the female part looks like? Or just walking into Home Depot, for example, and picking up a light bulb and just saying, hey, look, shooting a picture of it, and just say, okay, what is the fixture which goes with this particular light bulb and this kind of socket? Those are the kind of things which are very feasible and can be enabled in the next 5 to 10 years. There's nothing stopping from that from happening today. It's no longer a technology problem. It's really an implementation-ish thing. And all these things that I'm describing is, at some level, these have all been implemented in the autonomous vehicles like Tesla and these guys, where they're able to detect what's in front of you. Is it a cat or a dog or a person? And all those things have become enabled because of the commodity cameras. The cameras are very low cost. You can buy a webcam for less than $1 in China, and can put it in all different places and get any kind of information from these things, because the computations are becoming cheaper and cheaper and faster. So I don't know if that sort of answers your question, but.
Excellent. So, yeah, the questions are coming in. So I think you sparked some interest here. The first question, how do you calibrate measurement, establish traceability, and determine measurement uncertainty?
That's a good question. And let me just quickly show you a quick video of how it works, and it's sort of a lot of those things are visible in that. So these are all, on PhotoGAUGE's YouTube channel. So just go to youtube.com/PhotoGAUGE. A bunch of these things are there. And there is a setup. I mean, this is a case where you are trying to do this as a purely, a pure inspection tool to generate a full 3D scan. So here's an actually automotive knuckle. And what you can see in the picture is this calibration bar. And this calibration bar has been basically not only fabricated and stuff, but it's traceable back to NIST. So it comes with a certificate, and that's what allows you to get the accuracies within the system. The thing is and because these are non-moving things, this is just a solid bar. It only needs to be calibrated once, and after that, you're just using it. There is no wear and tear on it. There is no moving parts in it. So whether you take the measurement from it today or 100 times or 10,000 times the next year, there is no requirements for calibration or recalibration stuff. And that's what is used for calibration. And the process you can see in the video over here, it just goes around, takes a series of pictures of the part. So in this case, if you are using an automated turntable, it may take you, I don't know, give or take 2 or 3 minutes. All these videos are real time, so you can see that in 2 minutes you're able to shoot the entire thing. And then this automatically will generate a model, a full 3-dimensional model. And if the CAD model has been provided for it, it can be overlaid with that and provide you with all sorts of not only dimensional information, but what you will call heat maps or color maps showing how the part is deviating from the actual CAD specifications in what locations. And in this, or if you want, like this was an example where you were doing it on a turntable, but you can capture the same information by just walking around a die. So here's a picture of this is a 2,000-pound die, and all you have to do is just walk around it and get that information. And you can probably see that the calibration bars are just sitting on top of it. That's all. There is it's not like you have to, in a case of scanners or CMM machines, you have to, scanners, for example, the ATOF scanners, it'll take 15 to 20 minutes to just warm it up. And it took me maybe like a minute or 60 seconds to just shoot the entire part and get you the same level of accuracy that these complex scanners that have been around for decades are taking.
Excellent. So the next question we have, it says, what kind of camera is required, and how long does it take to get the data after you take your pictures?
So these are all using commodity cameras. So there is nothing special about it. It's for the fun. It's the usage of the camera is based on the kind of accuracy you are looking for. So a cell phone camera can get you an accuracy. Today's cell phone cameras can get you an accuracy of around plus minus 350 microns, which is about close to 10 to 12 tau. And if you want to go better than that, then you can use camera attachments. So here's an example where this is a 1-inch camera which is just attached to the cell phone. And the only thing is that what you're trying to do is basically get a higher accuracy. So by attaching this camera to it, you are able to now get to plus minus 100 microns, or more like what you call it, 4 tau to 5 tau. And if you want to go even tighter than that, you can use the Nikons with their physical lenses that are available at 28 millimeter lenses and stuff, and you can get down to 10 to 20 microns as well. What you start to trade in those cases is ease of use. Nothing beats the camera phone, right? You whip it out from your pocket, and if your tolerances are within plus minus 350 microns, you can just take pictures of that and upload it to the cloud, and you're done in no more than 60 seconds to 2 minutes. If you need the higher accuracies, then you have to attach some cameras and things like that to the phone and still repeat the same process. And it might take you 5 to 10 minutes to shoot those photographs. So, and from those pictures to conversion into a report that you saw, it's typically somewhere between 5 to 15 minutes at most. So this is an example of a lip that you're seeing. And once, it took if you look at the entire process on the video, this thing is about 6 or 7 minutes long. And from there, this is the report that the client got 10 minutes later. So there it is. So this is the report that automatically got generated from those photographs where where is the CAD part, it automatically shows where the these are the datum planes. So the scan automatically gets aligned to the datum planes and everything. And from there, you have generated a full GD&T report of like if the plates are parallel or not, if they're square or not, what the cylindricity of the holes are, if it's, what is the tolerance, what's the actual measurements, how much the deviation is, pass or fail, as well as like a full color map showing like, okay, here's a part, this thing, anything which is green and blue is within tolerance, something which is like purple is like, 1.3 inches out. Now, given this thing is, 20 feet long, those are, that's still pretty tight.
So was that model generated 100% from the photos, or was that also fed a CAD image to generate what we're looking at there?
No, it was all generated from the images. So the images actually, when it goes up, it actually generates the initial step. I mean, from if you guys are curious, this is the first step. With those photographs, it automatically generated this 3D point cloud, right? So when you take those pictures get uploaded, it took the first gentleman like about 5-6 minutes to shoot the part. Once they shot the part, this is what got generated automatically. But there is no point in sending this 3D model to them, because then they're saying, okay, now to go and pull out the measurement. And since they have shared the CAD model with PhotoGAUGE, the CAD model was automatically this data was automatically overlaid on it, and this is the report which got generated from that. So this is a report that they received about 10 minutes later, but which is all automated. There's no human involvement in it. So if you envision, I mean, if you're comparing that to things that you might be very used to in today's existing environment where you are using a scanner, the only thing a scanner is going to do is give you a scan, and after that, somebody has to take that scan and pull the measurement from it. So you need not only somebody who knows how to use different types of software, they have to know how to use a different type of CAD systems, pull that information within that, and then pull the measurements out. And that could easily be, a couple of hour long process where this thing is within 10 minutes of your photo shoot, you have the results.
Nice. The next question, I guess, is in regards to size of the object. Can you measure a complex object as big as 65 feet in length and 35 feet in width with very complex curvatures?
Yes. We actually are in contact. There are a couple of different coal companies who are looking at pulverizers and boilers which are at that kind of length. Even this object that you see, this thing is 20 feet long. So the limitations on the product is actually mostly on the smaller side. The bigger the part, the easier it is to shoot and easier it is to capture everything. Bulk of the challenges come in when the parts are small. When I say small, that means anything which is below 6 inches gets tricky because now you're running into the physical limitations of the camera and focusing on it. But there is no limitations when you are shooting big parts.
So one of the other questions it asks, what other type of drawings are acceptable besides CAD?
I mean, the CAD is, you can compare it against CAD, and if you don't have CAD models, which is also something which is quite common in the industry, then we need a gold, what you will call a gold part, or something that you say, okay, we know that this part is to the spec, and in that case, we'll compare it to that. But if otherwise, even you can still get an intermediary step that I showed you, which is that like, okay, you get the scan, and then from the scan, that you see on the screen, you can always pull measurements from it, but then you'll have to go manually and do all that, because if there is no CAD model, then you just don't know what do you want to know from this model. What is the measurement you want, and what is the data plane? I mean, how would you know that? That information all resides in a CAD model. And if you don't have a CAD model, then all the questions have to be asked and answered by a human. You can pull some of the geometric primitives that can be done. So when I say geometric primitives, if you say like, okay, Can you automatically detect holes and flat surfaces and tell me the distances between flat surfaces and the centers of the holes? Sure, you can automate those kind of features, which are regular geometric shapes, when you don't have a CAD model. But if you do have a CAD model, then it becomes easy, because then all you're doing is comparing it to the specifications and giving you an answer of whether it's within tolerance or not, or for that matter, the presence and absence of things as well, which is what was, I think, the examples that I was showing some of the earlier, some of the other examples. Where is it? Like all the questions that you've been asking so far are heavily revolving around the actual dimensional inspections. But it's, technologies are not necessarily limited to that. You can, this is an example which has nothing to do with dimensionality and accuracy of things. It's really all about, is the part correct or not, and that's based on an assembly. So the PhotoGAUGE can train in a system where, like, okay, is this part correct or not? And it's purely about presence or absence of all the components which are described in the assembly drawings or CAD models.
Excellent. So I think some folks are already interested in having a demo done in-house where they work. Do you have your contact information you can share on the screen?
Sure. Let's see where. I don't think I wrote it down here. Honestly, I can do that here.
And the next question that came up is, can you share any MSA data? Do you have any, like, sample reports, I guess?
Yeah, I think, most of the things that I have shared with you over here are actually on the PhotoGAUGE's website. So if you just go to photogauge.com, there's some sample as in the videos as well. And a bunch of them also on the, there's a lot more examples on the YouTube page, like photogauge.com/YouTube has a whole bunch of them. But if you just send me an email, I can just, fire off a sample report. So I think I'll just give you an example. Here's, oops. All right.
I have another question.
Sure.
So, when I was in Detroit, I worked in the automotive industry. I've been to places and they use similar technology for, like, reverse engineering parts for, like, 3D printing and stuff. So yeah. What is the market differentiator between PhotoGAUGE and the competitors' technology? What sets PhotoGAUGE apart from the different options out there?
I mean, reverse engineering is an extremely common use case that we have come across multiple times because of competitor parts is a very common practice, as well as parts which are where there is no CAD models available because they were made 20, 30 years ago or longer, and they need replacement. So how would you go about doing that? And those cases are all about reverse engineering. I think the issue in both, the existing technologies of for scanners have been around for decades. It's not something new. I think the key differentiator, if you look at it, is the fact that, like, almost all those solutions require those hardware, which takes time to warm up. It requires an expertise in how to operate the scanner. Then once you have, did the scan, which may take you easily a couple of hours to generate, the larger the part, the longer it takes. And then going from that scan to a CAD model is a manual effort. There is nothing automated about any of those things. Is PhotoGAUGE going to solve all that thing? No, it doesn't. What it has done is basically simplified your ability to shoot that, to basically take a video of that part in the field or in your lab, and which will take you no more than 2 to 3 minutes, and then 20 minutes later you will have a scan, which is, by the way, is not a CAD model. It does not have intelligence about surfaces and stuff. It looks like a full replica of whatever you've shot. But to go from there to a final CAD model for reverse engineering, it's somewhere between 1 to 2 days of effort to convert it into a CAD model from PhotoGAUGE's side. And if you want to just take the scan and convert it yourself, I mean, you can do that. It's it's a tedious process, and the scanners are only giving you a scan; they're not giving you a CAD model. So the question is like, how much is your time worth? If you are able to get a part, whether it's 15 inches or if it's 15 feet, it still takes you same amount of time to scan with PhotoGAUGE, which is just walking around and taking a video or series of photographs. And that's really the key benefit of camera-based technologies, are that they are in your pocket and they're very easy to use. You can hand it over to anyone. You can even do it remotely, like in some of the cases where we have given the cameras, like they wanted to do the shoot in the field in the mining industry. They wanted to replace something, and they're like, we did a Zoom call, just like this WebEx call, and we just asked the operator, okay, what do you want to shoot? And they showed us what they're doing. And it's like, okay, let's just go around the part. I was like, what do you mean go around the part? It was like, okay, just walk up, say, let's have the camera maybe about 12 inches away from the part. I said, okay, great. Now start walking. What do you mean walking? It's like walk around the part as you're shooting the part. And he finished walking in about 1 minute or 2 minutes, and that was it. That's the entire process. Here is another, and what I mean by that is, where is it? Might be a good example here where some person just did that. You know what? I might not have it here, but anyway, I don't know if that answers your question.
So another question came up, and I know we're probably jumping the gun a little bit. But what does PhotoGAUGE cost? Like, what's your cost model? Is it a subscription fee? Is it a yearly rate? Is it per user?
Yeah. So yes, it's something that we work out with the client based on the usage. So we work with you to understand what the problem is, but it's at the end of the day, it's a subscription-based model. So which is completely user-based. It's usage-based. So these are not. It's a solution where, like, if you are only doing, there are clients who are using PhotoGAUGE even if they're doing it only 4 to 5 times a year. And the reason is because the example that you saw of that lift, there's no way of shooting that lift without that 35,000-pound lift, especially if you want to do that right next to the furnaces so that you can stick the casting back in. And all the way to, like, people who are using it for inspections in the plastic bottles industry, where they want to basically every hour they are sampling 10 to 50 different bottles to see if they are within the specification, if they are within the spec. So in that case, it's a 24/7 operation, and they're shooting every hour 4 to 5 bottles. So it's a very different model in that case. To a third case where, like, they are shooting in the field with the cameras. There's a very large tire manufacturer, which is and that is their deployment. They are measuring tires in the field. So it's a sampling.
So another question came up. If you can verify the PhotoGAUGE images against shipyard DWI drawings, do you have any experience with those?
DWI drawings?
DWI.
I don't know what DWI is.
I'm not familiar with it either. I'll clarify. I don't know, Dave, if you want to clarify what a DWI drawing is.
Yeah. PhotoGAUGE's output is, if you care to get a scan for any reason, it can be, what you call it, it's an STL file. An STL file is a tessellated mesh. So it's a triangular data. And you can also get, automatically you can get what you call point clouds. So those are 3D points. You can get those kind of information if that's of importance to you for whatever reasons. But
I think it's a visual work instruction. Sorry, Dave, I don't think I have access to unmute you, but I think it's a visual work instruction is what DWI may mean.
No, I don't know what DWI is or visual work instructions. I think the
So I did write I have my last question here. That last question was from Dave Duffy at the Shipyard Drawing. He'll reach out to you via email. The last question I had is, what made you guys decide to use like an off-the-shelf cell phone for enabling your scanning? Why not go the route with dedicated equipment? What made you guys decide to, accompany PhotoGAUGE with just a regular iPhone?
That's a good question. I think it was, so when Shankar and I got together, this is like 5 years back, he was doing a sabbatical over at Google, and he was teaching at IIT in Madras in India, and he had moved back to India maybe 10, 15 years ago just because he wanted to teach. And his research was all about, given a picture, can you tell how much deterioration has happened in the metal or polymer or composite, whatever you're looking at over time. And he wanted to turn that into figure out if there is a way to convert it into a product and build a company around it. And we kicked around a lot of different ideas and stuff like that. And I think the key thing was, 5 years ago, it was like, hey, doing it using existing cameras or solutions would create the same kind of a problem that people already have, which is I need a dedicated device, I need a dedicated station, a dedicated room. People are asking that, hey, I want to get 10 microns. Well, if you want to get there, you need a clean room, vibration-free. The part has to sit there for 24 hours and before you can do that thing. But what sort of occurred to us was that, like, listen, you can capture the photographs from your cell phone camera. So, and they're only getting better and better. Meaning that, like, if you look at the rate of acceleration of how the commodity cameras or cell phone cameras have improved, it's dramatically better than anything that the industrial vision cameras have been able to achieve in the past 10, 15 years. And the reason is that those industrial cameras have not accelerated as fast. It's an investment decision. You have the resources of Apple and Google and Samsung and and Huawei all pouring in billions of dollars every year, because if you look at it, the cameras and the software innovation in the photograph have been a critical selling point for these guys for the past decade. It went from a single camera to front-facing cameras to now the latest cameras on all these. They have at least 3 to 4 cameras. And they're adding the sensor, now the 3D sensor on it. So to say that, like, the industrial cameras will be obsolete in the next few years, absolutely. I mean, you will not be, and it's basically a simple deal because they just don't have the kind of money that these giants are pouring now to improve the camera quality and the lens quality. And they have now these their lenses are being made, which are like, that are able to get you the DSLR qualities within the same form factor of a cell phone, which is like barely half an inch thick. So I mean, and that's what drove us that, like, you know what, let's stick with commodity cameras because this is where the whole world is heading, and this is the kind of, you know, the platform you want to be on. And that was our reason. So, you know, that's how we ended up there.
Yeah, the technology is definitely changing pretty rapidly. So I was able to pull up some visual work instruction documentation from NIST with a quick Google search. I kind of understand where Dave's going with this. So I want to ask a hypothetical question. So say
Sure.
we have an organization and we have several quality control technicians and they have their iPhones. They can essentially go out and take photos or videos out in the field. Now, because it syncs all with cloud-based solutions, there could be somebody in a central quality office looking at these scans in real time and making decisions on whether the quality is acceptable or not from a central office. How does that work?
It's quite simple. I mean, you can have multiple people in multiple different geographic locations all send in data simultaneously. It will all be processed simultaneously. And then you have the access to the PhotoGAUGE dashboard. So you just log in on the, photogauge.com/ your company name, and then, you have all those scans in front of you. So you can, compare the results with them and do all sorts of data analysis on it. If depending on the volume of it, you can then just you can dump the data out into spreadsheets and then, slice and dice it using that. I mean, and that's something I know, and to give you a simple example where, like, this truck manufacturer, so this tire manufacturer is a client of ours, is actually doing this thing with 18-wheelers in the field. So they are tracking how the tire is wearing every 5,000 miles across the 18 tires across 5 trucks. And all they're doing is every 5,000 miles, they take they just bend down, take a short video of the tires, each one of those 18 tires. They all get uploaded, and then the data that you're looking at is like, it's not only 18 wheels per vehicle, but across how they're trying to compare how different wheels on the 18 wheels are wearing down, but how they're also wearing across these 5 different trucks. And then comparing that data on, like, okay, what kind of a train and these guys are driving on, what is the load that they're carrying, what is the conditions, the temperature conditions in which these trucks are traveling, and that's to understand how the wear is happening. And then they're taking that data to basically put it back into their R&D innovation process of, like, hey, how can we modify these tires and what kind of a composition needs to be present to deal with these conditions versus some other conditions, such as, like, it's far more cold weather, to they are driving these trucks on rocks, to they are driving these trucks on tarmac. They're all behaving very differently. And that, so as far as they're concerned, they are handing the cameras, they're using the iPhone in the hands of the drivers who does not have any expertise in the scanning or understanding of GD&T or taking the measurements or taking the wrong measurements. All they're doing is, shooting a short video or taking, it's like, because everybody knows how to take a video and, and selfies, all those kind of things. And it's really that simple. And if they can make a mistake, well, sure, you can make a mistake, but that's all visible in the video. That, like, hey, your video was out of focus. How can you miss that? You can see that right there when you're shooting. And so that's what happens in a lot of these cases, that you're able to hand over the responsibility of actual data acquisition to technicians and drivers and people in the field, and all the heavy lifting of the data of once the model is reconstructed and the analysis all done in the back end by those handful of guys, as you said, who are doing and doing all the analysis.
So there's a couple other questions on this. The next one is, how customizable is the software to an organization's existing inspection?
What is the definition of customization? I mean, it's if let's assume that they already have an existing process, it's a matter of the customizations are predominantly revolving around two things: either the automation of actual data acquisition, or it could be the report itself. So the data that you're getting out of it. So it's all the solutions that we end up providing is purely based on that. So the truck example that I was giving you, in that case, the issue was, let's see, and where is it? Oh, I guess I closed it. You can repeat the next question or until I find this thing. So here's an example where the automation was done around this, for example, that, when I was giving you example of the trucks. So the customization we ended up doing is, again, is simply taking the photograph. When you're trying to shoot one wheel, it's cool. It's easy. Wow, wow, this is so easy. I can just pull out from my pocket and do it. But when you're doing it 18 wheels across a fleet of 50 or 100 of these trucks right next to each other, and the guy is there, all of a sudden, the problem is not the camera or anything, it's your back. Your back gives out. So in that case, the automation was actually just putting the camera on a rail and putting it down, and the guy just puts it down and taps it on the cell phone, and it moves and generates all the reports. Takes all the pictures, and then he moves the tire to the next thing. And in this case, then the customization was not only done for how to acquire the photos, but also on the reporting part, because like, how would you go about comparing 18 of these tires, and what is the methodology that you want to follow for comparing these tires? How would you, how do you know which tire it is? What is the methodology on that they want to capture? So those are the things that are completely driven by client. I mean, and in terms of like, what is their definition of customization and automation is.
Nice. Another question from Jeff Mass. It says, when you did the PolyWorks workspace of the Maynard list, how long did the initial workspace creation and report take to generate that data in that report? How long did the report take to generate?
It's between 5 to 10 minutes.
So it's pretty fast.
Yeah, it makes no difference to us whether the part is 2 inches or 2 feet or 20 feet or 10,000 pounds. It takes the same amount of time.
Another question is regards into facilities room. So say we have a boiler room, for example, and somebody wants to photograph it so they can get the diameter and length of pipe. Has anybody ever used it for something of that scale before?
Yeah, there's a client who is actually, they're in the wear and tear business in oil and gas industry, and that's their use case. They are going into a lot of these spaces, and they have to replace the pumps and the pipes in those facilities, and guess what? In order to do that, somebody has to either sit there and take those measurements using calipers and tape measures and try to get as many features as possible, or in our case, they basically are doing a 60-second video shoot.
So I want to go back to the previous question on the PolyWorks workspace. They were specifically asking how long it took for the workspace creation.
Workspace creation? Sorry, I didn't understand.
I'm assuming that's the 3D model.
BP model.
Maybe you could just clarify that, Jeff. The next question we had is, what is the smallest tolerance measurable with this technology?
That's a function of how far you are from the object. So it's a function, the accuracy of the system is completely dependent on the camera lens and the distance from the part. right? So it's not a technology limitation, it's a camera limitation. So you can take it down all the way to 10 microns and less if you want. It's just as I said, like, you can, but it all boils down to the camera. Using a cell phone camera, that's what I'm saying, it's 350 microns because that's in your pocket. But if you want to get down to 10 microns, you can use these Nikon or any of even the industrial cameras. The lenses are quite capable of taking you down all the way to 10 microns or less.
Excellent. So the last question I have here, unless anything else shows up, because I know it's almost time. It says, can the technology be used to check the alignment of various angles? For example, two gears pressed against each other.
The answer is yes. It's a function of, it's a line of sight technology. So if you can see it, if you can see it in a picture, you can measure it. So if the two gears are aligned, is you are able to see it with the naked eye, that means you can capture it with a camera. You can measure the distance or the depth or the clearance between the two gears.
All right, well, I know we're just over 7 o'clock. We appreciate everybody for calling in tonight to this presentation. Thank you very much, Azhar. I think you're going to have quite a few people calling you tomorrow. We had about 40 people, I think maybe 42 people joined at some point during the course of the presentation. So it wasn't our best turnout, but I think it was a lot of insight into not just what PhotoGAUGE does, but the technology in general and how it works. Because this is definitely where consumer and commercial grade inspection is going for these vision technologies. So we really appreciate you joining us today to do this presentation, especially I know you're on the other side of the world in a totally different time zone with us tonight.
No, thank you for inviting me, and those are very good questions. So happy to answer anything else if that's of interest and value, or just to figure out what are different ways people might be able to take advantage of PhotoGAUGE, or taking advantage of if you have a camera in your pocket. What are the possibilities? Happy to talk about that.
Excellent. Thank you very much. What I'll do is I'll contact you again via email to get your contact information. We will send out a small token of appreciation for you hosting your presentation with us tonight. Sure. Once again, I want to thank everybody for calling in for the ASQ Inspection Division presentation. This video was recorded, so it will be uploaded to YouTube at some point, and I will share that link with you once we get the video online, and maybe you can copy that over to your YouTube channel as well.
Okay, sounds good.
All right, thanks everybody. Have a good evening.